Derivative. Let's first define our derivative. Recall that we use the slope of the secant line to a function at the point A, f of A, to estimate the rate of change or the rate at which one variable changes in relation to another variable. The slope of the secant line passed through the point A, f of A, and x, f of x is given by the slope of the secant line equal f of x minus f of A divided by x minus A. So say you're given a curve, and this is the secant line, and the 2 point is A, f of A, and this is x, f of x. Then the slope of the secant line is given. We can estimate the slope of the tangent line by evaluating the limit at each approaches 0 in the different quotient. So this is the different quotient. Let's say the secant line is passed through the curve at 2 point. This is A, f of A, and A plus 8, f of A plus 8. This is our secant line. Then the tangent line can be estimated by letting the limit at each approaches 0 of the quotient of the different quotient. So this is the slope of the curve is by taking the limit of the different quotient, providing that this limit exists. So let's take a look at an example. Find the slope of the tangent line at x equals 3. Okay. So then we will let the secant line pass through the true point. F of 3 and 3 plus 8 f of 3 plus 8. Okay. Then the slope of the tangent line is equal to the limit at each approaches 0 of the different quotient f of 3 plus 8 minus f of 3 divided by 8. f of 3 plus 8 equals 4 times 3 plus 8 minus 3 plus 8 squared minus 12 minus 9. We will simplify the rational expression. So this is negative 8 minus 2, and we take the limit at each approaches 0. So the limit at each approaches 0 of negative 8 minus 2 This is equal to negative 2. So then the slope of the tangent line at x equals 3 at x equals 3 is negative 2. In part B, we want to write the equation of the tangent line at x equals 3. Well, in order to write an equation of the line, we need the slope and the y-intercept. So the tangent line passes through the point 3 and f of 3. So f of 3 is equal to 4 times 3 minus 3 squared, that is 3. So then y value equal 3. So y equal mx plus b. Here we have y equal 3. The slope equal negative 2. X equal 3. So b equal 9. So the tangent line, the equation of the tangent line is y equal negative 2x plus 9. The derivative as the rate of change. Okay. The derivative of the function f at the point x0 is denoted by f prime of x0. It is given by f prime of x0 equal the limit at h approaches 0 of x0 plus 8 minus f of x0 divided by 8. In other words here, the derivative at the point is the slope of the tangent line at that given point, provided that the limit is exceeded. Let's take a look at this next problem. We want to find f prime of 2. This means we want to find the slope of the tangent line at x equal 2. So f prime of 2 is equal to the limit at x approaches, as h approaches 0 of the quotient of the different quotient, that is f of 2 plus 8 minus f of 2 divided by 8 equal the limit at h approaches 0 of 2 plus 8 cubed minus 2 times 2 plus 8 plus 7 minus 2 cubed minus 2 times 2 plus 7 divided by 8. We'll go ahead and simplify this expression to get h cubed plus 6h squared minus 10h divided by 8, simplify by 8, at h approaches 0, this is equal to negative 10. So then f prime of 2 is equal to negative 10. What is the rate of change of the volume of the ball given by the function with respect to the radius when the radius is 2? So again, here we want to evaluate the derivative of v as the function of r when r equal 2. So what we are looking at is we want v prime of 2. That is the limit at 8 approaches 0 of v of r plus 8 minus v of r divided by 8. So v of r plus 8 3/4 pi times r plus 8 cubed minus 3/4 pi times r to the third divided by 8. Let's go ahead and factor out 3 pi over 4 pi. So this equals 3/4 pi times the limit at 8 approaches 0 of r plus 8 cubed minus r to the third divided by 8. This equals 3/4 pi times the limit at 8 approaches 0, and we will expand the numerator, simplify. This r simplify out. So we get h cubed plus 3r h squared plus 3r squared h divided by 8. This equals 3/4 pi times the limit at 8 approaches 0 of h squared plus 3r8 plus 3r squared equal to 3/4 pi times 3r squared. Now when r equal to v prime of 2 is equal to 3 pi over 4 times 3 times 2 squared, and that is 9 pi. Let's talk about vertical tangent line. We say a continuous function, we say a continuous curve y equal f of x have a vertical tangent line at the point where x equal to x naught if the limit of the different quotient is infinity or negative infinity. Okay. So let's take a look at this graph, and we want to show that it have a tangent line at x equal to 0. So again, we will calculate the limit at each approaches 0 of our different quotient, and we see that it results in either negative or positive infinity. So f prime of 0 is equal to the limit at each approaches 0 of f of 8 minus f of x, or f of 0, divided by 8. That is got a limit at 8 approaches 0 of 8 to the 1/5 minus 0 divided by 8. That is the limit at 8 approaches 0 of 1/8 to the 4/5. At 8 approaches 0, this number becomes smaller when we have 1 divided by a small number. This become infinity. So this telling us f of x equal x to the 1/5 has vertical asymptote. vertical tangent line at x equals 0. Okay. Similarly, for the next problem, let's talk about velocity and rate of change. Okay. When we're talking about the instantaneous velocity, we're actually talking about the slope of the tangent line of the curve at that point, okay, at the tangent point. Now that we can calculate derivative, we can use it in velocity application. Recall that if s of t is the portion of an object moving along a coordinate axis, the average velocity of the object is given by v average equal s of t minus f of a, and we can calculate the velocity by letting t approaching a. Okay, so how does this work? So let's take a look at this problem. For example, a lead weight on a spring oscillating up and down, its position at time t with respect to the fixed horizontal line is given by s of t equals sine of t. We want to estimate v of 0, and then we will verify your answer using the limit. So let's go ahead and calculate this by hand, and you can do this with a little calculator. So it seems like that the average velocity, is equal to 1. Okay, so let's double check this using our limit formula. V of 0 is equal to s prime of 0 is equal to limit at t approaches a, that is 0, of sine of t minus sine of 0 divided by t minus 0. This equal to the limit at t approaches 0 of sine of t divided by t is equal 1. So this verified. In the next problem, the homeowner set the thermostat so that the temperature in the house begin to drop from 70 degrees at 9 p.m. and reach a low of 60 degrees during the night, and rise back to 70 degrees by 7 a.m. the next morning. The temperature in the house is given by the function where t is between 0 and 10, and t is the number of hours past 9 o'clock. We want to find the instantaneous rate of change of temperature at midnight. Okay, so what does this mean? Well, since that at midnight, this is 3 hours past midnight, and we want to find how fast did the temperature change. Okay, is it increasing or decreasing at midnight? We do that by calculating the limit t prime of 3 is equal to the limit at t approaches 3 of t minus t of 3 divided by t minus 3. That is the limit at t approaches 3 of 0.4 t squared minus 4t plus 70 minus 61.6 divided by t minus 3. Simplify this. And this is negative 1.6. This meant that the temperature dropped at the rate of 1.6 degrees at midnight.